Hello all. So today we are going to say about the topic which is what you call that relative velocity method. So relative velocity method is nothing but generally whenever the mechanism or whenever the body which is in motion, we are going to find out what is the velocity of that moving body. We just go and calculate at point of movement. Okay, so in any point of that link, we just need to find out what is the velocity. So when there is a movement or when there is a displacement takes place because of the velocity, then we need to calculate about the acceleration. So that is what here we need to find out what is the relative velocity between the links, and how can we determine the velocity and how can we determine the acceleration for the given mechanism, that we can see in this lecture. So generally we are using two different methods. One is called relative velocity method and another one is called instantaneous center method. So relative velocity method means based upon using the free body diagram we use it to find out. Wherever the instantaneous means when there is a continuous movement which has been taken place in the given mechanism. So in that mechanism we need to find out at any point of that rotation or at any point of the movement, we just randomly take those points and find out the velocity. That is what you call the instantaneous center method. So here it is a procedure about uh, how to calculate the velocity for the given value or for the given mechanism. So here you just see that name A, here B of A vector, here it is a vector. Okay, so how can we represent that relative velocity of A with respect to B means V suffix AB, which means A depends upon B. That is what you call V suffix of AB, may be written in the vector form. So V of AB is equal to, it can be also written as an B with respect to A, that is what you call that BA vector, or otherwise the vector direction which travels from B to A, that is what you call BA vector, is equal to, it can be also written as an O of A vector minus of O of B vector. Okay, so here A, from the point A, that velocity which has been represented by V of A. From the point B, the velocity which has been represented by the V of B. Okay, so here the velocity which has been traveled from O of A, O to A, and similarly O to B. Okay, so O of A means the velocity direction which takes place from O to A, and O of B means the velocity which travels from O to B. That is what here O of A vector minus O of B vector. Okay, so the relative velocity of the two bodies moving along with the parallel lines. Similarly, if you are going to find out what is the relative velocity of the B with respect to A means, so here V of B vector minus of V of A vector, which means the velocity direction takes place from O to B and as well as O to A. So that is what here in this screen what you have seen can be represented. Okay, so these are some of the examples when there is a movement in the vehicle. So it may be a V of A or V of B. It can be represented by V of BA is equal to V of B vector minus of V of A vector, and similarly A of B vector to O of B vector. So that is what represented by using the schematic diagram. So here this is what you call that one of the extremities called B of the link move with respect to A but in clockwise direction. If there is a no relative motion, here there is a three different cases has been taken. One is B with respect to A about in terms of rotation that we calculated, and with respect to B again how the A point has been moved with respect to C. So that is what, there is a no relative motion takes place between A and B along with the line AB. Okay, so the relative motion of B with respect to A must be perpendicular. So that is what here the value of the V of B or BA has been represented in perpendicular direction to the link of AB. Okay, hence the velocity of the any point of the B with respect to the another point has been perpendicular to the line of any of these points. That is what represented by using this space diagram, and we will conclude the remaining in our next session. Thank you so much.